Hey Titans, welcome back to your second lesson for second week of online learning. It's Miss Cronky here. Great to have everybody. We're going to continue talking about parabolas, which is a topic that Mrs. Hillman introduced you to. You should be familiar already with this equation, x minus h squared equals 4p times y minus k. And I just want to point out that this is actually very similar to an equation for a parabola that you have seen before, as far back, I think, really as Algebra 1, but definitely in Algebra 2. So I'm going to take this equation and I am going to solve this equation for this y, which means I have to move all the things to the other side. Since y minus k is being multiplied by 4p, I would divide 4p from both sides. So I'm going to go ahead and multiply by the reciprocal. 1 over 4p times the quantity x minus h squared equals, and now I can just have that y minus k. And then if my goal is to solve for y, I can just add k to both sides. So I'm going to do a little symmetric property right here and say that y is equal to 1 over 4p times x minus h quantity squared plus k. And you might be looking at that equation and think, hey, that is a really familiar equation. Okay. If you did the Desmos activity, it was on that very first screen of the Desmos activity with parabolas. Looks something like this. In pre-calculus, we studied that in chapter 2. It was called the standard form in chapter 2. Back in algebra 2, we actually call it vertex form because the vertex is there, HK. Another way that sometimes you might hear it described is transformational form because A, H, and K represent transformations. So the cool thing about this is that if I look at this 1 over 4p and this a value, a is 1 over 4p. So think about what a would do to your parabola back in that old standard or vertex form. Well, a was responsible for vertically stretching and shrinking, okay, and also for reflecting your graph. So we saw some of those same ideas then with Mrs. Homan. If your p-value was positive, your parabola was going to open up. And if your p-value is negative, your parabola was going to open down. So we can say then that p is the directed distance from the vertex to the focus. The opposite of p is the distance, or is the direction that you would go for the directrix, because it sits behind the parabola. And because Mrs. Homan's equation that she looked at on the previous video is it has that x minus h quantity squared, just like the old form we saw, we've only really ever studied parabolas that open up and down because we're looking at them as functions. They need to pass the vertical line test. So what we're going to see today is a new standard form equation. Okay, it's an additional standard form equation. So I'm going to call it standard form equation. EQ apostrophe N, remember, is my abbreviation for equation of a parabola. And this is as a conic section. And the one that we're going to look at today looks like y minus k quantity squared equals 4p times the quantity x minus h. So really the big difference in this equation is that the y minus k and x minus h are swapping. Okay, which one is squared and which one is not. Side note, just to make kind of some connections here, you actually have seen parabolas that open left or right. That would go all the way to first semester Algebra 2. Let me grab a green pen here. So just as a quick side note, we know in Algebra 2, we spend a lot of time with y equals x squared, which of course its parent graph looks like a parabola that opens up vertex at the origin. But in chapter 5 of Algebra 2, you study radical functions. And so you take a look at y squared equals x. And when we graphed those in Algebra 2, what we did was we would solve for the y. So we would square root both sides. And then we say that y equals plus or minus square root x. And we know that the square root function, okay, that's the positive square root function. Here's the negative square root function, and we have a parabola that opens side to side. So you can kind of make a connection here with these two equations. If you have a y squared instead of an x squared, then you have a parabola that opens sideways. Note that we haven't really spent a lot of time studying this parabola because it isn't a function. It doesn't pass the vertical line test. Okay, so back to our equation here, y minus k quantity squared equals 4p times x minus h. Quick couple of things to note about this equation. Of course, p cannot equal 0. That would be pretty boring. And hk is still our vertex. Just be careful on these problems that you don't always assume that the one on the left is h and the one on the right is k. That you have to look at, like whether it's x or y as to whether it's h or k. And then we can say about our focus and our directrix. They are both p units from your vertex, just like Mrs. Homan told us. Okay. And then if you think about like what we were talking about up here at the top, p is the directed distance from the vertex to the focus. So when p is positive, okay, you're going to go right. When p is negative, you're going to go left to your focus. Okay, and we'll talk about that when we do examples. So we could add to this, I suppose, a little note to ourselves. If p is positive, and it has the y minus k squared, then the parabola opens right. And if p is negative, then the parabola opens left. Okay, and that goes back to that whole directed distance from the vertex to the focus. Okay, so let's look at an example. I'm going to give an example that I actually think is an easy example, but sometimes when they're this easy, they seem hard. So I'm going to give 2y squared equals x. Okay, so a lot of less stuff going on in this equation. If I think back to the equation that we were just looking at, the y minus k quantity squared equals 4p times x minus h. I can tell that this would be similar to this standard form because as I look at this equation, I do have a y squared. Okay. But one big difference is that in this equation, standard form, the y minus k quantity squared is all by itself. It doesn't have any coefficients, anything on the other sides besides the y minus k quantity squared, square of the binomial. So in this equation, in order to be able to kind of use this formula to help me out, I need to get y squared all by itself. So I would divide by 2, which of course is going to be the same thing as multiplying by 1/2. So now when I think about that equation that we have at the top of the screen, y minus k quantity squared equals 4p times x minus h, I can now pull out the important information that I would need to sketch a graph. So my vertex, my h and my k, are 0, 0. Okay, so we have a vertex at the origin. And then 4p must equal 1/2. I'm going to multiply both sides by 1/4 so that I know that p is 1/8. Okay. And if I'm graphing that, I'll go ahead and graph over here. Okay, I'll plot my vertex at 0, 0. And then remember, P is the distance to the focus and the directrix. So I'm going to go 1/8 to the focus and 1/8 to the directrix. Since P is positive, and I know that this is a y squared, so it opens right or left, I want to go to the right 1/8. So there's my focus point. Okay, I'll label that F for focus so that we can see that. And obviously I'm a little bit close, but it's hard for me to get, or sorry, a little bit more like 1/2, but it's hard for me to get close to that 0, 0 on here. So I'll just leave it as that. And then I'm going to go 1/8 to the left for my directrix. And the key here is that your directrix line for Mrs. Homan, you were always drawing horizontal lines, but now we're going to be drawing vertical lines because they're going to sit behind our parabola. Okay. So our parabola opens up around the focus. Notice that it never crosses the directrix. Okay. And there is an image of my parabola. I like to a lot of times like graph it first because then it's really easy for me to label my focus. How did I get to my focus? Well, I was at 0, 0. I went 1/8 to the right. So my focus point is at 1/8, 0. 1/8 to the right, 0 up or down. It's on the x-axis. And my directrix, if it's a side-to-side parabola, if it's a y-squared parabola, your directrix is going to be x equals a number. And in this case, it'll be -1/8 because we went backwards. So you should be able to identify that vertex, the focus point, those are both points, so they're xy ordered pairs, and the directrix, which is the equation of a line. Vertical or horizontal depends on whether it's an x-squared parabola or a y-squared parabola. All of ours today's are going to be x equals because the directrix is going to be vertical. And then those are things that I'm looking for on your graphs for your homework. And I'm also going to be looking, like when I look at your graph, do you have them in the correct spots? The focus and the directrix should be clearly labeled on the graph. And then does your graph open in the correct direction? Okay, so if you're missing some like h and k, just make sure you still solve for your x squared or your y squared before you start picking apart what is your p value. Okay, let's do another example. In this example, I'm going to give the equation y minus 4 quantity squared plus 12 times x plus 2 equals 0. So again, there's a little bit of work to be done right here at the beginning because it doesn't look exactly like our standard form. We want our standard form equation to look like y minus k quantity squared equals 4p times x minus h. So it's important that you have the y squared all by itself. In order to do that, I would subtract this term of 12 times x plus 2. So I'll have -12 times quantity x plus 2 on the other side. And now I can match up the different pieces. So it's pretty clear to me right now that my vertex, remember you got to do h and k. So h is with the x, will be -2, and k is with the y, +4. When I'm looking for my p-value, 4p should be equal to 12. So I'll do that over here. Sorry, 4p equals -12. So then p must be -3. Okay, so that's going to be my directed distance. And I'll go ahead and start graphing it. So I got to go 2 to the left and 4 up. 1, 2, 3, 4. Okay, so there's my vertex. And then because p was -3, remember that's a directed distance. I know because it's a y squared, I'm either going right or left to my focus. Since it's a -3, I'm actually going left. So I'm going to go from my vertex, I'm going to count 1, 2, oops, sorry. Here, I'll do it 1, 2, 3 to the left. I'm going to mark that as my focus, and then I can count in the other direction, 1, 2, 3. Right here is where my directrix should pass through. It's going to be a vertical line directrix again. Okay. And then I know that my parabola should open left. Let's see, I still need to label my focus and my directrix. And like I said, sometimes that's easier to do after you have your picture, so I can see from my picture, where is my focus actually at in relation to the origin. Okay, well, I'm going, if I go back to 0, 0, I'm going left 1, 2, 3, 4, 5. So that will be at -5. And then I'm still going up 4. Okay, and then some of us can probably make the connection that, like if our x was at -2 and we're going -3 to the left, then that's going to end us up over here at -5. And if we're at -2 and for our directrix, we're going to go 3 to the right, -2 plus 3 is going to land us at x equals +1, which of course matches what I see in my picture. Okay. So there we have it. Really important pieces. Make sure that you get this green equation right here. You got to manipulate it algebraically. Make sure that the y minus k squared is all by itself, or if you're doing a problem like Mrs. Homan's, make sure that x minus h squared is all by itself as well. All right, I'm going to do one last example with you guys. And that's going to be one of those where we have to rewrite. So I'm going to give us y squared minus 6y plus 4x plus 13 equals 0. When I'm looking at this equation, I can tell that it's going to be a parabola because as I look at all the different terms, I only have one term that's squared. And in this case, it's a y squared. So I know that it's a parabola that opens sideways, left or right. If I had only one variable squared and it was an x squared, then I would know it's going to be a parabola that opens up or down. So I'm going to rewrite this so that I can get that square of a binomial by completing my square, y squared minus 6y plus something plus 4x plus 13. And then we're going to subtract whatever we did to complete the square. So think about what numbers can complete the square for y squared minus 6y. That will be 9. We're taking half of -6 is -3. Square it to get a +9. The number that completes the square is always positive. And then we have to subtract 9 in the back. So we've just created y squared minus 6y plus 9, a perfect square trinomial. We like that because it factors to be y minus 3 times y minus 3, which I can write as the square root of a binomial, y minus 3 squared. And then I have plus 4x plus 4 equals 0. So it's looking a little bit better, like that equation that I gave you at the beginning of our notes. But remember, we always want the y squared to be all by itself. So we're going to move the 4x and the 4 to the other side. That will be y minus 3 quantity squared equals -4x minus 4. And then here's something you'll have to be really careful of. On the other side where it looks linear, so you've got the quadratic, the square of the binomial on the left, y minus 3 quantity squared. But on this other side where it looks to be linear, you have to be really careful with this very first term, whether it's in terms of x or in terms of y. That variable has to have like a leading coefficient of 1. So if there's any number in front of it, you have to factor that out of both terms so that it still looks like in a group of parentheses, x minus h, or in the other examples that we did in the previous notes, y minus k. So because there's a -4 in front of that x, I have to take out -4. Like I have to take out all of that. So I'm factoring -4 out of both terms. That's going to leave me with an x plus 1. And certainly, like, it doesn't have to always be a nice number. It could be a fraction. I'm giving you a nice number here, but it could be something different. Okay, so now this looks like our equation from the top, y minus k quantity squared equals 4p times x minus h. And there's what I'm talking about. This x has to be 1x. So you always factor something out if necessary. Hopefully you're getting kind of better at spying on what your p-value is going to be right here. Since it's -4 equals 4p, we can say off to the side over here that p is equal to -1. So again, it's a y-squared parabola. It's opening right or left. Since p is a negative value, we know that it's opening left. I can identify my vertex as my h and my k. So my h is going to be a -1, and my k is going to be a +3. You might want to challenge yourself a little bit here. Can you do focus and directrix without the graph to start? So just using your p-value. Up here, p is -1. Can you give me the coordinates for the focus and the coordinates for the directrix? Since we're at -1, 3, if we go in the directed distance, -1, left 1 to our focus, we're going to be at -2, 3. And if we go in the opposite direction to our directrix, we're going to go right 1. So our directrix line is going to be x equals 0, which is, of course, the y-axis. Okay, so I'll go ahead and sketch that. So I'm going left 2, up 3. Oh, that's my focus. Left 1, up 3, there's my vertex. Sometimes it's helpful to label the points, focus, vertex, etc., so you don't get them confused later. And then my directrix line, I'll actually switch over to a different color because it's on the y-axis. So here's my directrix line, x equals 0, and then I can draw my parabola, opening left. Okay. All right, we look forward to hearing your questions via email. We look forward to seeing your faces and hearing your questions in office hours. Do not hesitate to reach out to us. We are here and ready to help. You guys have a great day. Enjoy doing some problems on parabolas.